In our previous lesson, we learned how to multiply and divide basic radical expressions. In this lesson, we're going to talk about the binomial radical expressions, which means we're going to have a non-radical portion and a radical portion, similar to when we were adding complex numbers. So let's start with basic rules for addition and subtraction. If we have a times the nth root of x plus or minus b times the nth root of x, then our nth root of x item in both cases is going to count as a single variable and behave as such. So what we will end up with is the quantity a plus or minus b times the nth root of x. This is similar in idea to if I have 2w plus 3w. The w's act on their own. I just have 2 plus 3, which can be factored out of there, so I end up with 5w. Similar idea, now we're just using an nth root of x rather than a single variable w. So let's take a look at what this would be like. So we have 2 square root of 5 plus 8 square root of 5. So we can factor out of this a square root of 5, and when we do so, we have 2 plus 8. So 2 plus 8 is 10. Our answer is 10 square root of 5. This will work as long as we are dealing with the same type of roots with the same index and radicand. Let's look at our next item. We have 6x square root of 3 and 4x square root of 7. Because one is a square root of 3 and the other is a square root of 7, we cannot simplify this. So cannot simplify. This would be like trying to take 2x plus 3y. Because our variables are not the same, they cannot be combined. Same idea, because our radicals are not the same, they cannot be combined. Next one. We have 6 cubed root of 9 plus 3 fourth root of 27. Because one is a cube root and the other is a fourth root, again, we cannot combine these. So cannot simplify. And the justification here, or putting it back to something we've worked with before, be saying 2x plus 7x squared. One's linear, one is quadratic, and they cannot be combined because they're not talking about the same dimensions. So how can we go about the process of creating items that have the same radical and the same index if we start differently? Let's take a look. So if I have the square root of 50 plus the square root of 8, on first glance these are not compatible because they have different radicands. But as the directions here state, we're going to simplify first. So the square root of 50 is the square root of 25 times 2. And to that we're going to add the square root of 8, which is the square root of 4 times 2. Square root of 25 I can work with. That is 5, leaving me with a square root of 2 behind. And to that I'm going to add the square root of 4 is simply 2, leaving me with a square root of 2 behind. Now, we do have items that we are adding together that have the same radical portion. So, if I pull out a square root of 2, what does that leave behind? Well, it's 5 plus 2, so I end up with 7 times the square root of 2 as my final answer. Let's take a look at the next one. Maybe if that was a little bit fast, you'll get it on a second go around. So we have the cubed root of 128 minus 4 times the cubed root of 54. Well, the cubed root of 128 is the cubed root of 4 cubed times 2. That's 64 times 2. Minus 4 times the cubed root of 3 cubed times 2. 3 cubed is 27. 27 times 2 is 54. Now, pulling out our common items, the cubed root of 4 cubed is simply 4. So I have 4 cubed root of 2 minus 4 times the cubed root of 3 cubed is 3 cubed root of 2. That gives me 4 cubed root 2 minus 12 cubed root of 2. I can factor out a cubed root of 2, leaving me behind with a 4 minus 12. 4 minus 12 is negative 8, so I have negative 8 cubed root of 2 when I go to simplify this. So these answers, 7 square root 2 and negative 8 cubed root of 2, are simplified forms that are equivalent to what we started with. Now, adding and subtracting binomial expressions is a start, but we can also go a little bit further and begin to multiply and divide. So with multiplication, if I have the binomial 3 plus 6 square root 7, and I'm multiplying that by 2 minus the square root of 7, I can simply FOIL this out in order to get a simplified form. So 3 times 2 is 6. 3 times negative square root of 7 is minus 3 root 7. 6 root 7 times 2 is 12 root 7. And 6 root 7 times negative root 7 is negative 6 square root of 7 squared. Going through and combining like terms and simplifying, we have 6. Now, negative 3 root 7 plus 12 root 7 is positive 9 square root 7. Minus 6, the square root of 7 squared is 7. So I have 6 plus 9 root 7 minus 42. Combining my like terms, 6 minus 42 will give me a negative 36 plus 9 root 7. This answer is equivalent to the original, just has gone through the process of simplification. Now, next one. What happens if we multiply 2 plus the square root of 6 with 2 minus the square root of 6? So again, we're going to distribute. 2 times 2 is 4. 2 times negative root 6 is minus 2 root 6. Root 6 times 2 is plus 2 root 6. And root 6 times negative root 6 is minus the square root of 6 squared. Going through and combining like terms, negative 2 root 6 and a positive 2 root 6 will give me a 4. That simplifies to a 0, minus the square root of 6 squared is simply going to be 6. 4 minus 6 is a negative 2, and here is my final answer. Now, in this problem, we were able to get rid of the radical expression altogether because we used something similar to what we had back in complex numbers. These binomial expressions, 2 plus root 6 and 2 minus root 6, are conjugates, as we learned before. And the conjugates allow us to eliminate the undesired portion altogether, in this case the radicals, and leave behind only rational or real numbers. This is going to be very handy when it comes to simplifying division problems. So if we have the 2 square root of 10 divided by square root of 5 minus the square root of 2, for a simplified form we cannot have any radicals in our denominator. So we cannot have a square root of 5 and we cannot have a square root of 2. In order to eliminate these, or turn them from irrational numbers into rational, we are going to multiply by the conjugate of this expression. So instead of square root of 5 minus square root of 2, we're going to change the subtraction into addition and multiply. So we're going to multiply by the square root of 5 plus square root of 2 divided by square root of 5 plus square root of 2. And the reason we do this is because any item divided by itself is the number 1. Multiplying by 1 does not change our values. So going through and distributing, we have 2 root 10 times root 5. We get 2 root 50 plus 2 root 10 times root 2 is 2 root 20. That will be over square root of 5 times square root of 5 is the square root of 5 squared. That's here. Now square root of 5 times square root of 2 is plus the square root. 5 times 2 is 10. Negative square root 2 times square root of 5 is minus the square root of 10. And negative square root of 2 times square root of 2 is minus the square root of 2 squared. Now, simplifying this expression, in our denominator, we have a positive square root of 10, negative square root of 10, which when put together will simplify to a 0. Square root of 5 squared is simply 5. Square root of 2 squared is 2. So our denominator is 5 minus 2. Now, square root of 50 is the square root of 25 times 2. Square root of 25 is 5, so I end up with 2 times 5 root 2 plus square root of 20 is going to be the square root of 4 times 5. So I end up with 2 times 2 root 5. Simplifying this a step further, 2 times 5 is 10. So we have 10 root 2 plus 2 times 2 is 4. We have 4 root 5, all divided by 5 minus 2 is 3. So, a lot going on in this, but simply multiply it by the form of 1 of the complex conjugate and simplify the expression through distribution or foiling. Look over this. Make sure you have these concepts down because they're going to be needed as we move forward and continue our investigation of radical expressions and equations.